And welcome again. We are discussing some kind of law of dipole motion. And I would like to read the statement first. And that says an electric dipole P is in a uniform electric field. That's fine. The intensity vector E of which is parallel to the vector P. That means dipole moment and electric field vector are parallel to each other. How will the dipole move if it is rotated through a small angle alpha naught? Establish the law of motion of dipole. The moment of inertia of the dipole when rotating around an axis passing through its center and perpendicular to the dipole axis. Well, passing through its center and perpendicular to the dipole axis is equal to J. So let us direct the x-axis of the Cartesian coordinate system with the origin at the center of the dipole and along the direction of the vector E. And suppose that z-axis is perpendicular to vector E. So the angle of rotation of the dipole will be measured relative to the x-axis now, and the torque, that is P cross E, either write it M or torque. You can write it M vector or torque vector. In electricity they prefer to write it M vector, that is the moment and the moment of the force, and that can be written as simply as P cross E. And this is directed along the z-axis and it will act on the dipole from the electric field. So let us write the equation of moments for the dipole in projection onto the z-axis, and we can simply write its moment of inertia J, that is J d2 alpha upon dt square, and that is equal to moment of the electric field, and you can write it like this. And considering that the angle alpha is small enough, we can rewrite this equation simply as d2 alpha by dt square plus p e by j alpha, that is equal to 0. Just consider sin alpha is going to be equal to alpha simply in case alpha is very small, and this is the equation of harmonic oscillations with frequency omega, angular frequency of the rotation, equal to P E upon J, and taking into account the initial condition, the law of motion of dipole has the form alpha equals alpha naught cos under root omega t, and alpha is the angle of deviation of dipole axis from the direction of the electric field E, and dipole makes a small oscillations around the z-axis with a time period that can also be written as t equals 2 pi by omega, that is 2 pi under root j by p, and I don't see it cannot be wrong, and this is simplest of the problems. Thank you very much for watching.